All right, Precalc, we're continuing our work, but now we are working in parabolas. We are on chapter 9, lesson 1, and we know what we know about parabolas is we know that an x squared parabola is going to be a positive, and it will look like a U, a negative, and it will look like an upside down U. So the equation that we have for an x squared parabola is x minus h quantity squared equals 4p times y minus k. Now, if we have a y squared parabola, this is new for us in pre-calc. Y minus k quantity squared equals 4p times x minus h. But notice if it's positive, it's going to be a curve of a C. And if it's negative, it's going to be the other way, like a backwards C. And these two equations down here is if the parabola goes through the origin. So notice there is no HK. So the only difference here is there is no HK. Now we have to know a couple of things about the parabola. The first thing we know is it's in the shape of a U. I'll just put it at the origin. And we know it has a pattern of over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7. And remember we get that because anything squared is going to have that pattern. I always make my students memorize their x squares. So we know 1 squared is 1, 2 squared is 4, 3 squared 9, 16, 25. Well, if you look inside of here, they go up by the odd numbers. And that's why we do over 1, up 1, over 1, up 3, over 1, up 5. And if you want to see more videos, you can look at my Algebra 2 section. I have a video of 7.5, and those are my parabolas. But today we're going to learn a couple new things. The first thing we're going to learn is we have parabolas that have what we call a focus. A focus is a dot in the middle of a parabola. And notice the parabola hugs the focus. The directrix is a line, so we will have to write the directrix as a line. The directrix is a line, and it is of equidistance. So notice from here to here and here to here, we're of equal distance from the vertex of the parabola to the focus and the vertex of the parabola to the directrix. Now the cool thing is it is of equidistance from here to here, here to here. Now obviously my pictures are not drawn to scale. I apologize, but I'm not a very good artist. All right, so let's look at example 4. It says, find the standard equation of the parabola with a vertex at 3, 2 and a focus at 1, 2. Well, I know the vertex is at 3, 2. Well, you know what? I'm just going to go ahead and focus right here. The vertex was at 3, 2, and the focus was at 1, 2. So the first thing I'm going to do is I always graph it. I know at positive 3, positive 2, I have my vertex. I know at positive 1, positive 2, I have my focus. So this tells me, hey, this parabola is going to hug this focus, and I have to write the standard equation. So because I know what I know that this is going to be a y squared and I also know that this is a negative because it's a backwards looking C. So let's put in what I know. I know that the vertex is 3, 2. So the 3 is going to go next to my x, and 2 is going to go next to my y. I also know I was given a focus of 1, 2, so I do have to find the distance from here to here. So since it is 1, 2 steps away, I'm going to plug that into P. P is the distance from the vertex to the focus or the vertex to the directrix. So my final answer is y minus 2 quantity squared is equal to 8 times x minus 3. All right, let's continue with these parabolas. We're going to make them as simple as we can go. My next question says, find the focus of the parabola given by this mess. Y equals negative 1/6 x squared plus 4x minus 2. So I'm just going to focus on this right here. The first thing I want to do is get rid of the 1/6. And how I'm going to do that is I'm going to multiply it over. So I have negative 6. I can multiply each side by negative 6. Negative 6y is equal to x squared plus 4x minus 2. Now, since this can't complete the square, I have to complete the square because I know that this is going to be an x squared. How do I know that? Because that's the only thing that I have squared. And I know that this isn't a perfect square, but I got to make it into a perfect square. So I'm going to add that 2 over. Negative 6y plus 2 equals x squared plus 4x, and good old algebra 2 is going to come into play. I need to complete the square on each side. So we take half of the b term, 4, and we square it to get 4. When I add to one side, I add to the other. And I get negative 6y plus 6 is equal to, notice this is, my whole goal was making this a perfect square. So this perfect square is x plus 2 quantity squared. I had to look back at what the question said. The question says to find the focus. I'm not there yet, but I'm getting awfully close. So I do have to factor out a negative 6 because I want this to be in parentheses, y minus 1 and x plus 2 quantity squared. So this, well, I guess the first thing we need to see is my vertex. I know my vertex is at negative 2, positive 1, and then this 6, negative 6 right here, I'm going to graph it just so we can see it again. Negative 2, positive 1. I know it's an x squared negative. Okay, so when I graph it, over 1, down 1, over 1, down 3. So I know my focus has to be somewhere inside of that parabola. So this negative 6 right here, if negative 6 is equal to 4p, when I divide each side by 4, isn't p equal to negative 3/2? Well, remember negative 3/2 is 1.5, so I know that I'm going to put my little focus right there, but I actually have to name the point. The focus point is at negative 2. This was up at 1, and I went 1/2, so it's negative 2 and negative 1/2. All right, we're going to do one more because sometimes we really struggle with these parabolas. Find the standard form of the equation of the parabola with a vertex at 1,3 and a focus at 1,5. Well, I know my vertex is at 1,3. I like to graph everything. I like to picture them. I also know my focus was at 1,5. Well, if that's here, I know my parabola is going to be an x squared positive. So I know I'm going to have an x squared positive. First thing I do is I plug in that vertex. This is the h, this is the k, h, k. And then I'm going to look for the distance from here to here. That gives me my p. Well, in this case, p is 2. I have 4 times p, which is 8. So it looks like my standard form of the equation of the parabola with a vertex at 1,3 and a focus at 1,5 is x minus 1 quantity squared equals 8 times y minus 3.